Alright guys, so today is the 8th, so it's 9, 8, and we're going over one-step equations. One-step equations. I'm on page 3. Alright, so let's go ahead and get started. We're going to open up to page 3, wherever our next page is. Title it One-Step Equations. And I'm going to draw a line about an inch from the red, straight down. And the first thing we're going to go over is we're going to go over some vocab words. So the first word I want to talk about is isolate. So isolate in this sense, what we're using for is saying to get the variable by itself. So we need to isolate the variable, get the variable by itself. Okay, so what is a variable? Well, a variable is an unknown value. It's a number we do not know. Some common variables we're going to see: x, y, z, a, h, k, etc. Right? Pretty much any letter of the alphabet can be used as a variable. Constant. What is a constant? Well, if a variable is an unknown value, a constant is a known value. It's a number that does not change. Alright? It's a number that does not change. It's a number without a variable. So it's a constant, does not change. It is the number without a variable. We know what the value of it is of the constant. We can quantify it. Next term is coefficient. So the coefficient is a number attached to a variable. And it's attached to the variable by either multiplication or division. And the last thing we're going to go over vocabulary-wise is inverse operation. So inverse operation, what that is the opposite of the given value, expression, or equation. Opposite of the given value, expression, or equation. Okay, so examples. So we're going to look at this equation, 2x plus 4 equals 8. And there's a reason why I spaced it out the way I did. So the 2 in front here is what we call the coefficient. Okay, it's attached to the variable, right? The x being the variable, and in this case it's attached by multiplication. So that would be my coefficient. The x itself is my variable. It's my unknown value. I cannot quantify it just yet. I can solve for it, but we don't know what the value of that x is. And then the 4 and the 8 are actually both constants because we can quantify their values. We know what 4 is. We know what 8 is. They're known values, and they do not have a variable attached to them. Okay, next thing we're going to do is talk about the steps to solve. Well, the reason they're called one-step equations is because guess what? There's only one step. And that step is to isolate the variable by using the inverse operation. Isolate the variable by using the inverse operation. Okay, we're going to work out some examples. So first up, x minus 7 equals 10. So x is a variable I'm trying to solve for. That's what I need to solve for, is the x. So in order to do so, the first thing I'm going to do is I'm going to draw my wall. That way I know whatever I do to the left side of the wall, I have to do to the right and vice versa. Right? We have to balance it out. So whatever I do here, I have to do to the other side. So I need to get x by itself to isolate the variable. The way to do that is I have to get rid of this right here. So this is read as x minus 7. Well, we need to do the inverse operation, right? Well, the inverse operation of subtracting 7 would be adding 7. What I do to one side, I also have to do to the other, right? Now, this adding 7, it only adds to the constant. Okay, it does not add to the variable. Constants can only go with constants. Variables go with variables. All right. So what happens here is I have negative 7 plus 7. Well, negative 7 plus 7 is 0. They'll disappear. And the only thing I'll be left with is this variable, and we're going to bring it down. And then 10 plus 7 is 17. Now, how do I know if that's the correct answer? Well, what I can do is I can plug the answer in. So I'm going to rewrite the equation over here. All right. And what I did was when I solved this equation, x equals 17, I gave a numerical value to the variable x. I know what the value of x is. I'm saying the value of x is 17. So what I'm going to do is I'm going to take this 17 and I'm going to plug it in for that x right there. So anywhere I have x in my equation, I can now replace it with 17. So I'm going to replace the x with 17. Everything else stays the same. Well, 17 minus 7 is 10, and nothing else happens to the right side. It's still 10. Now, this right here, if this is a true statement, then my answer is correct. So does 10 equal 10? Yes, it does. That is a true statement. So since this is true, the x is equal to 17. That is my correct answer. 17 is the correct answer. Now, if I did not get a true statement here, so if I got something like 8 equals 10, then what that tells me is that this is not the correct answer and then not the correct value for x. Alright, so all I'm doing here is this is just me checking my work. I'm checking my answer to make sure that that is the correct answer that will work. So next problem, I have 5 plus k equals 2. So first thing, draw my wall. Now, the variable I'm solving for is k, which means I need to get rid of this 5. So this may be 5 plus k. But you have to remember that this 5 over here is also positive, right? That's positive 5, not negative 5, positive 5. So in order to get rid of the positive 5, I'm going to do the inverse operation of positive 5, which would be negative 5. Because remember, inverse operation doesn't just mean, it also can be the opposite of the given value, not just a given expression or equation. So since I'm given the value of positive 5, I'm going to do the opposite of positive 5 and subtract 5. What I do to one side, I also have to do to the other. 5 minus 5 is 0. They'll cancel out. I'm going to bring the k down. And then I have 2 minus 5. Well, 2 minus 5, if I draw out my number line and everything, and I do it right, or even if I just write it out, 2 minus 5, I'm going to end up getting negative 3. So again, we're going to check our answer first. So I have 5 plus k equals 2. Except this time, the negative 3 is going to go where the k is. So I'm going to have 5 plus negative 3 equals 2. So this 5 plus negative 3 is the same thing as saying 5 minus 3. Well, 5 minus 3 is 2. And does 2 equal 2? Yes, it does. That's a true statement. Since it is a true statement, therefore, this is the correct answer. Well, how about 4x equals 8? So now this time I'm still solving for x. Right? Let me draw my wall first. So I'm still solving for x. But this time, this 4 is attached to the x, right? This is the coefficient now. Remember, coefficients are attached by multiplication or division. And in this case, this is 4 times x. So if I have multiplication, in order to do the inverse operation of multiplication, and to get rid of the 4, I would need to divide, because the inverse operation of multiplication is division. So I'm going to divide. I'm dividing by the 4. The reason I divide by the 4 is because I want to keep the x and get rid of everything else. 4 divided by 4, it cancels out to, not to 0, but it cancels out to 1. So technically I actually have 1x over here. But remember, if I have a 1 in front of the variable, I don't need to have that 1, I can just get rid of it. What I do to one side, remember I have to do to the other. 8 divided by 4 is 2. And then think about that. What times 4 will give me 8? Well, 2 times 4 gives me 8. So I can expect that to be the correct answer.